All right, a specific exponential situation that it seems like they have a lot on the College Board test is Newton's law of cooling. So Newton's law of cooling is an exponential equation, but it has a little twist to it where so if something is cooling in a room, like you have a warm pie, then the temperature, the rate of change of the temperature is proportional to the difference in the temperature of the room and the temperature of the thing. So this works for dead bodies, it works for pies, it works for cups of tea, it also works for hard-boiled egg. So a hard-boiled egg is at 98 degrees Celsius. It's put in a pan under running 18 degrees Celsius water to cool. So the differential equation for the egg's temperature over time is this differential equation, which is Newton's law of cooling. And after 5 minutes, the egg is 38 degrees. How long does it take to reach 20 degrees? So this one, we are going to separate out the variables again. So we have dt divided by t minus 18 is equal to negative k dt. And I'm just going to emphasize this is the equation for the egg's temperature over time. So T is the temperature of the egg. I don't know if you could hear that when I pronounced that T, but it was a big T. And lowercase t is time. So then if we do the antiderivative of both sides, we have natural log of t minus 18, because the chain rule doesn't really do anything to that derivative, minus kt. And the really good news is that if the temperature of the water is 18 degrees, the egg is never going to be any cooler than 18 degrees. So these absolute value bars are not necessary. So we can just write that as natural log of big T minus 18. Because we know that the egg won't be any colder than the water that we're running it in. So then we're going to exponentiate both sides, and so we have big T minus 18 is equal to negative e to the negative kt. And then we can add 18. Oh, I forgot plus c. I forgot plus c. I forgot plus c. And that plus c goes into the exponent. So actually we have t minus 18 is equal to, remember we're going to do that same trick with the e to the c. So we're going to say p e to the negative kt. And then we're going to add 18 to both sides. So t is equal to p e to the negative kt plus 18. But we have two different problems. We have p and we have k. So we need those initial conditions in order to figure out what those are. So when t is equal to 0, the egg is 98 degrees. So when we put 0 into this equation, we get 98 is equal to p plus 18. So our initial condition is really the difference in the temperature of the egg and the temperature of the room. So P is equal to 80. And so then we're going to use our P. And the other condition we have is that when T is equal to 5, big T is equal to 38. So we can use that to figure out what K is. So 38 is equal to 80e to the negative K times 5 plus 18. So 20 equals 80 e to the negative k 5. And then divide by 80. So 1/4 is equal to e to the negative k times 5. Natural log both sides. So natural log of 1/4 is equal to negative k times 5. Divide by negative 5. So k is equal to natural log of 1/4 divided by negative 5. Now we have the equation that we need. So we used our initial condition to figure out P. We used 5 minutes later to figure out K. And now we have the full equation. So we have that the temperature of the egg is going to be 80 e to the negative K, except we know K. So I'm going to fill that in. E to the negative negative, so it's going to be natural log of 1/4 divided by 5 times t plus 18. And so this is our equation, and we're going to try to figure out how long it takes to reach 20 degrees. So we're going to set that equal to 20. So grab your grapher. That's our next step. So we're going to put our equation in to graph it. 80 times, make sure you use the E button. And we're going to have to change our window, but the other thing we want to graph, so I'm going to go ahead and do that, is going to be 20, so we can see where they intersect. So I'm going to change my window, and in my window settings, I'm going to make sure that my Ymax is 20. I'm going to make it 25 so I can make sure I can see it. Oh, and look, I can see where they intersect already. So I'm going to go Menu, Analyze Graph Intersection, and I messed up. Menu, Analyze Graph Intersection, so we can figure out where they cross. And it looks like it's 5. Did I forget the 18? I might have. Let me see. Oh, I did. I forgot to put the plus 18 in here. Now I can't see where they intersect, so I'm going to change my window so I can see where they intersect. And I'm going to make this 20. Now I can see where they intersect. So in case you missed it, the mistake I made was I entered my equation in wrong. I forgot the plus 18. So now I've got the correct equations, find out where they intersect. And it looks like it takes 13.305 minutes for my egg to cool to a temperature that I like it, which actually I think is too cold, but that's okay. All right. That is exponential growth, and it's also Newton's law of cooling. Thank you so much. Bye.